Thank you everyone for joining. We're going to get started now. My name is Kevin Jones. I'm a senior product manager working for Nginx, and I'm also the lead mentor at Growic for the Solidity track. And today we're going to be talking about how to deploy a NFT and a decentralized application for your NFTs using a toolkit called Scaffold ETH. This is actually part of the Growic curriculum. So you can actually learn what we're doing as part of the curriculum and more using a toolkit called Scaffold ETH. So let's get started. I'll share my screen here. Okay, cool. So again, my name is Kevin, also known as shutterblock.eth. You can find me on Twitter as Crypto Mastery. Again, I'm an evangelist for Nginx and a product manager, but I'm also a developer advocate for a toolkit called Scaffold ETH, which is basically a toolkit for prototyping and building on Ethereum quickly, building dApps. And I'm also the lead Solidity mentor at Growic. And in my free time, I'm a photographer and filmmaker. If you guys scan this, you can get all of my social media and my contact information so that you can reach out to me if you guys have any questions afterward. And we will take questions at the end of the presentation as well. So first of all, this webinar is sponsored by Growic. Growic is on a mission to make higher education collegeless, admissionless, and tuitionless, and really just kind of give skills to individuals without the need of college, and to create a community for people that want to learn in technology. The overall goal of the Solidity track specifically is to help Web 2 developers transition to Web 3 and land a job in the Web 3 industry. And by doing the course, you'll kind of learn how to create and develop smart contracts, how to deploy your decentralized application, and you'll be able to show a copy of your work that you've completed on GitHub. You'll learn pretty much everything you need to get started as a Solidity developer. And it's a total of 8 weeks self-paced content that's available on Growic. And there is a bunch of mentors that are involved, including myself, on a Discord server so that you can kind of get involved in the community, ask for help. And we do weekly online sessions as well, where you can kind of come on a Zoom session or Google Meet and kind of ask questions to me or one of the other mentors. And yeah, just really build a community around learning. Everything is available online. You can go to growic.com and you can register for the curriculum just by going there now. And again, everything is really flexible and self-paced so that you can do it at your own disposal. And it's very interactive as well. Like I said, you can interact and work with other people on Discord. And yeah, with that being said, we're going to get started here and talk a little bit about, I do want to give a brief intro to people that maybe want to understand a little bit about what Web3 is, what NFTs are, and this kind of concepts. Web3 is this whole new way of kind of building on the web, whereas traditional applications use hosted infrastructure and are deployed on, cloud servers or maybe bare metal servers. Web3 architecture is completely decentralized, right? It's this concept of blockchain-based applications, deploying dApps, and those dApps and providers. A dApp is just a decentralized application, so it's an application that lives in a decentralized manner. And these dApps or providers connect to nodes on the blockchain, right? So you have users that connect to the dApp, and then the dApp connects to the blockchain, and you can make transactions, right? And it's permissionless in the sense that anyone can interact with the blockchain or with the decentralized network by the use of public key cryptography. This also makes it immutable and somewhat censorship resistant, where if you actually deploy your application, they're deployed as what are called smart contracts, which are basically just programs written in popular languages like Solidity or Viper and deployed onto the blockchain and allow you to transact really in a way that's, again, permissionless and immutable. If you develop an application, you can actually make it so that it'll technically last forever on the blockchain. And everything else is transparent. So, everything you do, all your transactions, all of your code, for the most part, is transacted in a transparent way. And that's kind of like the core concept of building a dApp. So what does that look like from a developer standpoint? So developers will develop their applications usually in some kind of front-end framework, usually JavaScript, common frameworks like React or Next. And they're usually deployed in a way that's on a decentralized, distributed way, right? Either a decentralized protocol like IPFS, which is the interplanetary file system, which allows you to deploy your assets in a decentralized network way, or using something like Arweave, which allows you to pay up front for your storage costs and deploy your application onto the Arweave network. That application will technically live forever in a decentralized way. And then smart contracts, which are the backbone and the core to the application logic, is stored in smart contracts and pushed to the Ethereum blockchain. In this case, we're going to be talking about Ethereum. And the code is stored there and verified on the public ledger on what are called blocks, right? All of the confines of the contract are self-executing. So in other words, how you write the logic in the smart contract is kind of expected and understood based on the programming that you do. And it removes the need for an intermediary, because these smart contracts can actually act as a bank. And so you can store value in these contracts, extract value from these contracts. There's no need to go through some kind of banking system or cloud provider or third party. Everything is stored in this decentralized way. And again, it's permissionless. Anyone can interact with it. And again, most of the smart contracts are written in something like Solidity. There's also a popular one called Viper. We're going to be talking mainly about Solidity today. And again, there's JavaScript libraries that sit on top that allow you to really easily interact with the blockchain. Things like Web3.js or ethers.js. Again, all of these either providers or nodes connect to the blockchain using either APIs, or you can interact directly by sending transactions. So what does that look like from an actual standpoint of what we're going to be talking today? Well, we're going to be talking about Scaffold ETH. So Scaffold ETH is a toolkit. Again, it's open source. It's available on GitHub. If you do a Google search for Scaffold ETH, it'll be the first thing that pops up. And it is this toolkit that allows you to easily spin up a full Boolean development environment that contains HardHat, React, and pretty much all of the glue. Everything is kind of ready to go for you. One of the biggest things about developing on Ethereum is it can be kind of difficult to kind of get up and running with all the basic stuff that you need to build the dapp. So all you have to do is check out the repository, do a yarn install that will install all of the dependencies. So everything in Scaffold ETH is built around this concept of using yarn. Yarn is kind of like a package manager, and then it also allows you to run scripts from yarn as well. So all the scripts are pre-wrote and all the dependencies are pre-wrote. So all you need to do is check out the repository, run yarn install. Then you can run yarn chain. Yarn chain is going to spin up a copy of HardHat on your local machine, on localhost. And then you can run yarn start to spin up a copy of React. And React is the front end that we use to interact with the blockchain. Then you do a yarn deploy, which basically takes a copy of the Hello World smart contract that comes with Scaffold ETH, and then you can deploy that to your chain, to your HardHat chain. And as you interact with the blockchain and through your dapp, all those changes are getting stored locally on your private blockchain. So it's really a way to kind of mimic the Ethereum virtual machine locally and kind of start toying around and building. So we're going to show another version of this, which is it's called the simple NFT example. And it's actually the first challenge that you come to after you've gone through all the basics of Solidity on the Growic course. And it's also part of what's called Speedrun Ethereum, which is a kind of like a learning tool for going through kind of quests. And it just involves a separate repository, which is basically called the Scaffold ETH challenges directory. And this, again, is all part of the curriculum, so you'll have access to this. And then you check out that specific example using that using Git, and then do the same process. Do a yarn install to basically install all the dependencies, do a yarn chain to spin up the blockchain, do a yarn start to spin up React, yarn deploy, and then as you interact with the application, all the changes will be saved. And then you can go through and start doing more deployments. So if you do get lost at all, you can, there's Scaffold ETH docs. There's also a Growic Discord channel. So if you guys want to hop on there, you can kind of get involved. Again, if you join the course, you'll have an access to the Discord server, and you can join that and get going. So that being said, let's get out of this. And let's take a look first. So I mentioned that the GitHub repository for Scaffold ETH is available. You can do a quick search for it. It has all of the steps in here for you to get started. So don't feel like you have to follow along with me or try to do this today. You can come back to this later. After you get Scaffold ETH kind of up and running using those commands that I talked about, the next thing you'll want to do is go to Solidity by example. And this is kind of like little examples and snippets that you can copy and paste from Solidity's from the Solidity by example site into your smart contract and then toy around. Eventually, you'll work your way up as you get through the Growic curriculum to go to Speedrun Ethereum, and you'll start doing these challenges. And these challenges, the first one is what we're going to look at today, which is called the simple NFT example. And you can actually start doing a quest and kind of walk through that process. And the Scaffold ETH challenges repository is here as well. It's also part of the Scaffold ETH account. So if you click Scaffold ETH, you can see the Scaffold ETH basic repository, which is like the core version. And then this is the challenges repository. So I've already kind of set up a couple windows for us to kind of like to start kind of looking at what we're going to be doing. I am using what's called tmux, which is just a terminal multiplexer. And essentially what it does is it just gives me the ability to have multiple windows up. So you could just do this in separate windows. With Scaffold ETH, you always kind of have to have 3 windows up. So in this first window, what we're going to do, we've already kind of checked out the directory. So we can take a look inside and see what that looks like. We've already checked everything out. The first thing you're going to do is do what's called a yarn install, right? All the dependencies, you're going to install in those. I've already gone through and done that. When you first do it the first time, it takes about a minute, but we're up and running. We're ready to go. So then I'm going to do yarn chain, like I mentioned. And what yarn chain is going to do is just spin up what's called HardHat. It's just this local host blockchain that has kind of like some play ether in it that you can kind of like use to deploy your smart contract and to interact with your dapp. Then we're going to go over to the next window here, and we're going to do a yarn start. This also takes about a minute to get going, but what it's going to do is it's going to spin up a copy of React on localhost port 3000. So we'll give that a second to get going. And then in that third window is where you're going to do your deployment. So we're going to do a yarn deploy. So out of the box, Scaffold ETH, and by the way, I'm showing you the basic Scaffold ETH first, and then we're going to show the simple NFT example. Out of the box, it comes with a smart contract, and then we're going to go over that and show you what that does. But you can see as we deployed, we're automatically interacting with the blockchain. We can see that there was a transaction that was made, and we can also see that our contract has been deployed to a specific address. And we can see how long it took, and we can also see how much gas it took. You can think of gas as kind of like this, like power. Well, it's a currency. You have to pay up front for gas to do something on the blockchain. So to deploy your contract, you have to pay a little bit of gas. To interact with your contract and make changes to state inside of the contract, you also have to pay some gas. So this thing tells us how much gas we used, and it tells us where it was deployed at. And we can see up here on the right-hand corner that also React is up and running. So if I come over here, we can see that we're up and running and ready to go. So there's this cool option where you can kind of do like night mode. So we'll switch it to night mode. And when you first get started with Scaffold ETH, this is what you come to, right? This is kind of like the bare bones project that you get. And you'll see that there's all these tabs here. The first tab is where you would like build your app. So if you're proficient in React, or if you want to start building your app around your smart contract, you would build it here in this app home directory. It kind of just has some examples and tells you where to get started to go down that route. What's really useful though is this next tab, which is the debug contracts folder. What it does is it automatically takes a copy of your smart contracts, what's called an ABI. So when you compile your smart contract with the yarn deploy command over here, it builds what's called an ABI. And it's basically an application binary interface, which allows, it basically tells your dapp how to interact with it, because when you compile it down, it's in bytecode. So the ABI is automatically injected, and then also Scaffold ETH automatically builds some kind of like functions here that allow you to interact with your smart contract based on what functions you've defined or what variables you defined. So we can see that there's a variable defined already, and that there's a function as well that allows us to update that variable. So before we go too further into the UI, I'm going to bring up a copy of the code so that we can kind of go through it and see what this looks like underneath. So I use one called Atom. You can use whatever editor you want. I just like Atom because it has built-in Git integration, and it's got some built-in like linting and syntax highlighting and stuff like that. So you'll notice in the directory structure for Scaffold ETH, there's a folder called HardHat, there's a folder called React, there's a folder called services and subgraph. You're pretty much only going to be working in either the HardHat directory or the React app directory. Eventually, you might get into doing what's called a subgraph, which is a GraphQL API using what's called the graph. But we're not going to get to that today. We're just going to be focusing on HardHat, and we're going to focus a little bit on React as well. So if we look in here, there's this contracts directory. And inside this contracts directory is that kind of like hello world contract. And we can see that inside the contract, we have this build unstoppable apps string, which is basically just a variable that is publicly available called the purpose. Then we have a new function here that is there in the UI. It's called set purpose, which allows us to push over whatever we want, any kind of string, and update that purpose. So we could hard code something here. We could do permissionless apps like that and save it. And then we could come over here and just do another deploy. And after we do that deploy, let's just see if it succeeds. We could make that hard-coded change and we can see it deployed successfully. So if we come to our app, now we'll see that the variable is updated. So we can toy around and tinker, like I was telling you before, if we go to like Solidity by example, and like, I don't know, let's say we want to look at primitive data types and we want to say, well, let's define up some variables, right? So we could like grab those here and then we could like paste those in, right? And we got 2 new variables we've created, save that, and then we could do another deployment, right? So you get in this kind of like habit where you're basically going through and you are making changes, and now we're seeing those variables pop up in our smart contract. So you got this kind of like loop where you're doing, you don't need to worry about HardHat, it's going to do its thing, React is running, and you're just going to really be operating in this kind of deployment, edit, deployment, etc. So that being said, so let's keep going real quick through the UI. So there's also like a hints folder, which tells you like maybe some hints about how you can get started. And we also see that there is an example UI tab, which gives you some examples of how you build like an input, or how you would like show an address or ENS, or show a balance or something like that. And then you have a mainnet DAI contract, which is a copy of the mainnet DAI, which is basically like DAI is a stable coin. So this is a copy of the contract in case you want to like send some DAI to your account here. And then we have the subgraph, which we won't get into that, but this is for the graph. It has built-in graph support. So another thing you'll notice up here on the top is we have this wallet here as well. So you don't need to use like a browser wallet. You might have heard of what's called MetaMask, which is like a browser wallet. Scaffold ETH comes with what's called a burner wallet. So you're ready to go, and it's got this automatically account that's generated. And then we see that it doesn't have any money. And we also see that we can connect our wallet. If we wanted to use MetaMask, we could, but we're not going to get with MetaMask. We're just going to utilize the burner wallet. And we can see the wallet here. We can do things like look at the private key. We can send some money around if we had some funds in our account. And then on the bottom left down here, we also have like the current ETH price, and we have the current kind of gas station price, like how much is it going to cost to transact on the Ethereum blockchain with what's called gas, because it's a market value and it changes. Again, for development, you're not going to need to worry about too much about gas because we have unlimited funds to play around with. And then we have the support channel. If you want to get help, you can go there and you can get access to the Telegram channel for Scaffold ETH. But what's important too is we also have a wallet that allows us to pull funds. So what we can do is we can grab our address here, copy it. Or we could also just click this little get funds and that'll send us some money. So we can say, all right, cool, I got some funds. Now I got $17 in ETH, which is a 0.01 ETH. Or if I want to get more, I can come down here, paste my address in, and let's say I want to toy around with like, I don't know, $1,000 bucks. So now I have 0.58 ETH and I have $1,000 of toy ETH kind of in my burner wallet to transact. So that's a real good run through of what the Scaffold ETH UI looks like. Now let's actually get to the simple NFT example. So I'm going to go ahead and I'm going to stop this version, and we're going to open up this one, which is just basically another tab that I have set up. And again, I've already gone through and I've come in here and I've already done yarn install. Let's just make sure that I have all my packages installed. We're good to go. Now I can do yarn chain on this version. So I'm spinning up another version of that. And then I can also do a yarn start to start up React. And then I can come down here and I can do a yarn deploy. Okay. So I'm deploying the what's called the year collectible or the simple NFT example. And the simple NFT example is basically, again, it's the first challenge that you come to pretty much after you kind of get through the basics of Solidity. So we can actually go back. Let's do localhost 3000, see if it spun up. There it is. It's up and running. Okay. So now we're in a completely kind of new branch of Scaffold ETH. Okay. And this is kind of the core of what I want to talk about today. You got a second to look and see how Scaffold ETH is built. So now that we have a copy of this version, we can see that some things have changed, right? So let's go ahead and close this version of Atom, and let's open up this branch of Scaffold ETH, and let's see what's different. So particularly inside the HardHat directory, inside the contracts, we have what's called your collectible.sol, which your collectible is just we renamed it basically. It's still the basic contract that comes with it. And what we can see here is that we actually are doing we're doing some inheritance. So Solidity, when you write in Solidity, you have the ability to inherit other contracts. And so we're using a handful of Open Zeppelin contracts. Open Zeppelin is kind of like a company that writes solid, secure, trustworthy contracts, and that have all of the basic functionality for different standards. And so for NFTs, there's two kinds of standards. There's ERC721 and there's ERC1155. We're going to be doing ERC721 today, which is pretty much the pure NFT or the most basic version of an NFT. The main difference between 721 and 1155 is that you can actually, it's semi-fungible, so you can have multiple copies of a specific NFT. But for this case, we're going to be just using ERC721. And you don't have to understand all this code, but what you have to understand is that we have imported these existing contracts that are kind of the standard, and it's already written for us, so we don't have to worry about anything. It's got all of the inheritance already completed here. So we're inheriting 721 in numeral, 721 storage, which is for like storing the URI, and the ownable, which ownable is an access control functionality. And we're also using what's called counters, which is a way to just basically count automatically and keep track of a particular series. So with NFTs, you usually have what's called an index, which is a counter to how many NFTs you're minting. And we have the constructor, which the constructor is what is run the very, very first time that you deploy your smart contract. So in this case, it's called your collectible, and it has a symbol of YCB. This can be customized for whatever you want. And then we have like some overrides that we're doing on the existing function. So within Solidity, you can inherit a particular contract like we're doing there, but that you can also override those. And we can do that by overriding special settings for different functions. So in other words, the base URI already exists in ERC721. So we're gonna change something a little bit. So if you see something that says override, then you'll know that you're actually overriding whatever inherited function that you're doing. And really, there's not much to this. There's kind of a lot here, but it's really the main functionality of what we're going to be talking about today is this function here, and pretty much this function. The base URI is kind of where the metadata for your NFT is going to be stored. So the most common place to do that is something like IPFS. So we're using IPFS for all of the storage for our NFTs, for our metadata. And metadata is just like the information that stores like where you can access the image, what kind of traits that NFT has, maybe the description, the name. And then there's this mint item function, right? And the mint item is really keeping track of where you want to mint that NFT to, what the URI should be. So we're taking in a variable called address, which address variables are like Ethereum addresses. And then we're taking a string of the URI, and then we're returning back the token ID using a uint256. And so that's what we're doing here. So we're referencing these other functions within this function, which is the safe mint and set the token URI. And then we're incrementing as we add more tokens and mint more NFTs. We're incrementing the token counter, which is basically keeping track of how many we've tokenized. So you don't need to understand that too much, but if you want to get into ERC721 and learn more about it, this is where you'll make changes if you want to like update anything. We're not going to be making too many changes in here. We're just going to show how you can deploy the NFT. So that being said, we're going back to the UI, and we can see here that, again, we have this ability to grab some funds from the faucet. And we also have like we can send money to the faucet a different way. And we're doing everything on localhost. And I can just simply do mint NFT. So I can access this function and mint an NFT. What this is going to do is it's going to actually just grab inside of, let's go back to the thing here, and let's go to React. And let's look at source, and let's look at app. So I mentioned earlier that you might be toying around with the React as well. So app.jsx is the main component for Scaffold ETH. And there's a lot going on in here because there's a lot of inheritance we do, and like there's a lot of references to other parts of the contract. Eventually you'll get through this. As you go through the course, you'll basically learn to kind of like edit some things here, like if you want to update your network, which we're going to do here in a little bit. And then we can see what the starting JSON is for this, these other tabs. So we have this, first we have the year collectible, which has the mint option. Then we have transfers, which keeps track of where these NFTs are being transferred around. So let's show that real quick. Let's open up a incognito tab. And let's go to the localhost 3000 on that one. And what we'll see now is we have actually a new wallet. We have a new wallet. So we have, this is our existing wallet that was generated for this one. Then we have this kind of like different blocky, different address. He doesn't have any money. He doesn't have any NFTs. And we could just grab the address here, and then we could actually transfer this NFT right here. So we can just say transfer, and it's going to successfully transfer. And then that NFT is going to show up over on this user's account. So you can automatically mint NFTs, transfer them around. I can mint one over here. If I try to mint one, it's going to tell me I don't have any money because, or don't have any, I don't have the upfront cost to actually mint the NFTs. So I'll have to get some funds and then mint the NFT. And then I'll get a second NFT here. And then I could take that one and send it over here if I want. Like maybe I don't want the zebra, I'll send the zebra back over to this other account. We can send it over here. So you can see how you can create NFTs, mint them. Now, if you look, there's this, like, they're just kind of randomly being generated. Inside of the functionality here, which I believe that it's in, let's see, I gotta find it real quick. Themes. Actually, I think it's in app. Okay, they're here. So there's this kind of like JSON structure that is available inside of the app.jsx. And we can see that that's where the information is getting pulled from. So this very, very first iteration is the bison, right? And it's got a link to the external URL, which is like basically pointing to Austin Griffith's website. So all these paintings were actually created by Austin Griffith, the creator of Scaffold ETH. So this points to his website that shows where all of his paintings are. And then you can see that inside the metadata, this is just the metadata. And inside the metadata is a copy to the URL for the image, and then a name for that NFT, what you want to name it, and then the attributes. So like, what is the background color for that image? What is the eyes? They're googly eyes. What's its stamina? Like if it was like something part of a game and you wanted to create like maybe a tokenized value or something like that. And so this metadata is actually what's getting pushed to what's called IPFS, and it's stored on IPFS. And then the NFT is pointing to this URI. So if you wanted to, you could basically come in here and rewrite these this metadata, point to your own images, and then you could start minting your own NFTs using that mint functionality. There also is a what's called a batch mint functionality as well inside the HardHat directory. So again, there's two components to it, right? There's HardHat, which will allow you to deploy stuff using HardHat, and then there's the UI, which allows you to mint NFTs using the UI. You also have this other functionality in here that's under scripts called mint.js. Now, what this does is it allows you to run yarn mint, and it allows you to put in your own front-end address. So let's do that. First, let's send the zebra back over here. So we'll get rid of it and transfer it. So now it'll go away. It's over here. So now this guy doesn't have any NFTs, but let's grab the address that we have here for this, this primary account that we've been using. And let's update the mint.js file that comes in here with the address there, save it. And now we can come over here and do a yarn mint. What this is going to do is it's going to grab and mint all of the NFTs for this particular user. So we can see that it started working, and we can come over here and the NFTs are starting to appear in the account. And you'll notice that it's keeping track of the numbers as well. So it completed in 11 seconds. So we minted 4 NFTs. And it also shows us the IPFS hash. So if we wanted to, we could look at that hash. Let's do that actually. So let's grab a hash. Let's grab this one here for the zebra. And let's go to this IPFS download option and put the hash in here and then download it. And then we get the metadata. So this is actually doing a GET request to IPFS. Again, you can think of IPFS as just a file storage, and you're just basically storing the metadata there. And then you can also upload your own here as well. So like if you wanted to test what that would look like, this is just a form that allows you to upload directly to IPFS here. If you do that, you click upload to IPFS and it gives you the hash back. So then I can grab that hash, look over here. So you could custom write your stuff. You don't even have to technically go into the UI. You can technically mint NFTs directly using there. I don't know why that keeps coming up, but that was happening earlier. And then, so let's go to the debug contracts folder and take a look. So you can see that this particular contract is a lot more extensive than what we were using before with the simple example. And that's because it has all of the inherited functions that come with the ERC721 standard. So things like being able to approve a NFT to be basically transacted or sent somewhere else. You can get a list of approved NFTs. It's all these like base functionality that comes with. You also have the mint functionality. You have the name of the collectible. You have the owner of the contract. You'll see here that it transferred the owner automatically of the contract for me as well. It did that inside of the mint.js script right here, which is the very last step, is it actually transfers a copy of the address ownership right here to me so that I'm the owner. So you can think of this mint.js as kind of like the way to mint a bunch of NFTs and then transfer the ownership of the contract as well. Because smart contracts have to have an owner, because you know, they're the ones that have to be able to, like, if you're doing access control, call certain functions. Yeah, so let's keep going. So let's say that you've gone in here and you've created your own metadata. You've uploaded your own images, you've changed the metadata names, the traits, and you've built an NFT collection. Well, it's only on your local host, right? You could just deploy it straight to mainnet, but most of the time you're probably not going to do that. You're going to just deploy it to a testnet first, right? So to do that, you can think of, again, like HardHat has this functionality where you can essentially either deploy locally, or you can deploy with HardHat to a network, either testnets or mainnet. Mainnet is obviously like the main Ethereum blockchain. So usually what you would do is you would build your dapp, localhost, test it, make sure that your NFTs are working, you can just send them around, all the metadata is right. Then you would push it to a testnet, right? So we'll see right here that there's this functionality called default network, okay? Default network is kind of like the local host, right? HardHat instance. So what we can do is actually, we can do what's called Coven. So Coven is another test network. There's also Rinkeby. So we're going to deploy to Coven. That's because I have some Coven funds that I can use. And we're going to save that. So first, we're going to update the Coven there. Then what we're going to do is we need to, because we want to deploy to a testnet, we need to use testnet funds. So in order to do that, we need to generate a account that HardHat can use that has a special reserved mnemonic or a passphrase or password. And so we're going to do yarn generate to generate a new deployer account. Okay. And this generator account is going to create a account right here. And then it sets the mnemonic inside of packages HardHat. The mnemonic is kind of like the passphrase, the password. I'll show it to you guys because I'm not going to use it for anything else, but you can see it here. It generates it inside the HardHat directory, and here's the contract address, or sorry, the external owner account, the wallet address, and here's the password. So if you were to take this and put it in a MetaMask, you could essentially transact with the Ethereum blockchain using that. But I'm just messing around with test ETH. It's fine. We've already generated that. So now what I can do is I have a wallet on my phone. So what I can do is I have some test Ether. I have 0.98 ETH in here inside my Punk wallet, punkwallet.io. You can get a little mobile wallet. And what I can do is I can do a yarn account. And I can take my wallet here, run a yarn account, get a list of the deployer account, and I'll get a QR code here, and then I'll scan it, and then I'll send myself, I don't know, I'll just send 10 bucks of kind of like toy money, right? I gotta run it again. Boom, boom, boom. Okay, cool, that was successful. So now if I run yarn account again, basically I've taken some funds from my burner wallet, not my burner wallet, my Punk wallet, and you can see now that I have inside Coven, I have 0.01 ETH. So I transferred 0.01 ETH from my wallet on my phone directly to my my Coven account. So now what I can do is that I've generated this and I've got the proper network set up. So now I should be able to do a yarn deploy, and I can deploy my changes. But after I deploy my changes, I also need to update my front end. So I need to actually go into my app, which it looks like it deployed successfully. Oh, wait, yep, did it. There it goes. It's deploying right now. It's a little slower on a test net, but we can see that it deployed and that worked. It took 18 seconds. So now what I can do is come into my app, go to source, go to app.jsx, and let's update the network here as well. So we not only have to update HardHat to point to the test net, we also have to do it here. So let's do Coven. Let's save that. And then let's refresh our app here. So now we can see here that we've got Coven, and we don't have any ETH on that account, but we know that it's working. We should be able to mint NFTs here as well. So what we can do, actually I have some testnet on my MetaMask account. So let's sign into here. And let's make sure we're on the right network. It automatically tells me and detects that I'm on the wrong network. I need to be on Coven. And then we should have some funds here. Let's see if it worked. Oh, you know what? I don't have any funds here, but that's okay. Let me load it up in a different browser with a different wallet. Let's open a new one here. This one, I know I have some funds. So let's connect my MetaMask wallet here. Unlock it. Okay, switch to the right network. So it also, a couple of these have that ability where it basically detects that you're on the wrong network. So now we have, there's my cryptomaster.eth account. I have $176 in Coven ETH. So now I can mint an NFT here on Coven, so on the testnet. So if I mint NFT, it's gonna give me, this is gonna be a little different because we're using MetaMask. It's gonna ask me to sign the transaction. It's gonna tell me how much gas it's gonna take, and I can just hit confirm. And might take a second. Obviously, everything on a testnet is going to be a little bit slower than your local host because you're not like doing authenticated transactions right away, but boom, there we go. So we took our smart contract, we built it, in Git using yarn install. We didn't change any of the metadata because that would be a little bit too involved, but if you wanted to, you could change the metadata, change the image. I don't know why these errors are coming up. Then we were able to take that smart contract, deploy it to a test net, and then we were able to also change our UI to point to the testnet as well using Kovan. The next step would be that you're going to deploy your application to somewhere else other than your local host, right? So that way you guys can actually interact with it, right? So how would you go to that step? So the next final step is taking our source code that we've written and essentially push it. There's some things that you should do before you do that. One of the most important ones is in this constants folder. There's an area for API keys, and you should update and add your own Infura API key and your own Etherscan API key. Etherscan is a way that you can verify your contract on Etherscan, and then Infura is a way to make calls not using your own Ethereum node, as I mentioned before, by using a provider. Infura is a provider that gives you access to the blockchain DAI. So you would eventually want to put your own Infura API key in here and your own Etherscan API key. But let's build our package. So again, the last step, we've deployed it already on Kovan. We've changed the app to point to Kovan. Now we can do a Yarn build. Yarn build is going to take a little bit of time because what it's going to do is basically create a production build of all of the assets for React. And it's going to compile those down and shrink them down to as basically a smaller form. Okay, so this, again, it created all these files that we needed. So now we can do what's called Yarn Surge. And Yarn Surge is going to basically prompt us for the name that we want to use. So let's call this one Growic-simple NFT .surge.sh. And we're going to upload that. So if you guys are at home today, you can actually go to this URL here in a second, and we'll do it here as well. That's it. We uploaded it. So let's take a look and see if it works. Let's go to our new tab. Oh. And let's go there. Boom. So it works. So now we have our app on a Surge endpoint. So Surge is kind of like a hosting provider that just allows you to send static files there for free up to a certain size. And then we can connect our wallet again. Let's connect our MetaMask. And let's sign it. Let's make sure we're signed in, and then we should see our NFT. There we go. So now we have a testnet NFT deployed using Scaffold ETH, and we've not only done it on our local host, developed it, we've pushed it to a testnet. We've also pushed the dapp to the testnet as well. Okay, cool. Well, I really appreciate all of you guys coming. I do see something in chat. Let's see if we have a question. Nope. No questions. Okay, so if you do have any questions at all afterwards, I'm available on Twitter as cryptomastery_. You can also join the Discord if you sign up for the curriculum. I will be, doing a lot of the content and a lot of the mentorship. So if you guys have any questions at all, I'll be on the Discord channel as well. So Twitter or Discord, either one is good. So thank you guys so much for coming, and I hope you guys enjoy the rest of your day.